A very good morning to one and all present here. It is a great pleasure for me to welcome you all to the 11th edition of Alumni Research Talks organized by the Computer Science Association, BITS Pilani. Computer Science Association is the departmental association for the Department of Computer Science. CSA stands as a powerful learning platform with substantial inflow of guidance and mentorship from seniors. The association has an open nature, thus allowing the convergence of computer science enthusiasts from all streams of study. CSA is noted for organizing quizzing and coding events around the year, as well as innovative events such as anti-coding and capture the flag during Apogee and the Alumni Research Talks. The first edition of ART was held in the year 2012, and after its tremendous success, it has continued as an annual event. Today marks the beginning of the 11th edition of ART, and our first speaker is Ms. Mansi Gupta. Mansi engineers machine learning and natural language processing solutions to real-world problems and is particularly interested in exploring explainability, fairness, and biases in ML models. She got her bachelor's in computer science at BITS Pilani in 2015. She graduated from a master's program at Language Technologies Institute at Carnegie Mellon University. Mansi previously worked as an applied research engineer with the spam and relevance team at LinkedIn, where she worked on modeling user interactions and end-to-end search systems. Till recently, Mansi was a part of the trends and event detection team at Twitter, where she wrote algorithms to surface trends and recent events on Twitter, rank them, and contextualize them with meaningful information. Now, she is joining Google to keep YouTube safe from harmful content. I would like to now request Ms. Mansi to take the stage for the talk.
Thank you so much, Chaitanya, and nice to meet you, everyone. I wish we could meet in person, but that's okay. Here we are. I will talk about like a few questions that I think would be in minds of a lot of people. How to find a good fit for a career in machine learning. Although I am talking from the lens of machine learning, but I think the talk would be relevant to people who do not want to go in machine learning, who want for like people in CS and even like people outside computer science, like general like tech careers. And I want the session to be interactive. Please feel free to ask any questions. I'll try my best to answer them. So let me, yeah. So now, like why all of you should listen to me. So I am an undergrad from BITS Pilani. I did computer science in BITS Pilani from 2011 to 15. I did my master's in machine learning from Carnegie Mellon. I have a few publications. I like a master's gave me an opportunity to observe academia closely, and I worked as both as a software engineer and more on like the machine learning side. I have some experience in big companies and some experience at a startup. And I have a lot of friends with like pretty divergent paths. They have done like a lot of very different things in their life. So some of them have, for instance, even become like yoga instructor after doing CS undergrad from BITS Pilani. So my path is more, the beaten track. But so I do have like friends with very divergent paths, who I talk to, etc. So why to not listen to me? I just have a 5-year long career. I don't have like decades long career. I only have a vicarious experience of PhD. So my husband just finished his PhD. He is also a BITS Pilani CS undergrad. I myself have not done a PhD, but like I have a lot of friends that did that, and I decided like I very consciously decided to not do a PhD. So I feel that I have the perspective from the other side. I am not a professional career counselor, and I have not conducted like any large scale research. Whatever I am speaking comes from mostly from experience and talking to people and things like that. And I realize that I have been like very lucky to be where I am. So it is definitely like a parochial view coming from a position of privilege. So just a few caveats here. And yeah, so let's dive right deep into it. So when you think of a career, um, how do you assess a particular decision, or how do you think of a long term career? So like I personally, I distill it down to these four things. One is impact, the impact that you want to have in your life through your career in whatever like 40 years you of the working life you have, the skills that you bring to table, the value that you gain from it, mostly like talking from monetary perspective, and then whether a particular career is a good fit or not. So I feel that like what the different factors that we think about while choosing a career can be distilled down to these four. So so let's talk a little bit about impact. So so when I talk about impact, I talk about um, uh, uh, the result of your work on the world. And so you work for about 40 years and about 50 weeks in a year, and let's say 40 hours a week. So you have about 80,000 working hours in your career. And if you want to have a positive impact with your life, there are other ways to do that. You can obviously do it in like non-career ways, but I feel that your choice of a career is like the best opportunity to do that. So so now how to choose careers that or how to solve problems that are so like the engineers like tend to think in terms of solving problems and solve optimization and efficiency. So how to uh, how to have the most like meaningful impact, how to optimize for that for impact. So there are three things. One is so how to choose those problems that you want to optimize for. So choose the problems that are large in scale, that are solvable. Solvable in the sense that they should not be problems that are like that you cannot do anything about. For instance, terrorism might be one of the problems that require more of global cooperation, and as an individual, one cannot do much about. And the problems that are neglected, like not a lot of people are looking at those problems, so that you yourself are not like completely replaceable. So I think of it this way: like if there are a lot of very qualified people ready to do the job that you do, then probably the problem that you are solving is not as much neglected. Um, so uh, so now I would want to I want to guide you to this organization called 80,000hours.org. So they exactly research about what I just talked about. Basically, they help students and recent graduates find careers to effectively tackle the world's most pressing problems. So some of the problems that they have identified that fall into these categories that are large in scale, solvable, and neglected are related to, say, climate change or health, solving like health in poor countries, and then research and nuclear security and things like that. But at the top of their list is positively shaping the development of artificial intelligence. This is what they think is the most impactful problem of our times. I would not. So if I start talking about the AI safety related issues, it would take like the entirety of this talk. So I think I will move on to the topics we want to discuss. But I definitely want to, if you take one thing from this talk, I would like definitely endorse 80,000 hours.org. Just check it out and see for yourself. And you would like know more about like how to choose an impactful career. Um, so before I go to the second part, which is skills, are there any questions?
Yes, ma'am. There are two questions in the chat box. First of
Okay,
all, Aryan Kumar wants to ask, how did you look for a job after masters?
okay. And okay, so the other question is, okay, one question is how did you look for a job after masters? Okay, let me read the second question. Do you recommend chasing L5 to L6 offers for a stable start in the field, or go for a position in a startup after finishing the undergrad or masters? Okay, so as most of you would expect, both of these questions um, do not have like a very clear answer. Looking for a job after masters is fairly like straightforward. You submit your resume to 500 companies and say like 30 of them get back to you. You interview with say 15 of them, and then you get an offer from 5 of them, and then you negotiate. So this is the or you get an internship and then get a pre-placement offer. So it is kind of like this is what like everyone does, and this is what I did as well. So the next question is so the next question is basically choosing between a startup or masters or a bigger company. I will go into this a little later. So bear with me. And if I have not answered your question till the end, I'll take it up towards the end. Okay. So anything else, or I'll move on. Okay. So yeah. Okay. So let's talk about skills. So skills is one of the only things that you have in your control. Other things are either your personal values, which you cannot like really very quickly change, or your fit, which is probably genetic or whatever. Like it is very very hard to change. Skills are the only things that you can like really control. So here I think the only thing I would want to say is uh, so uh, so everyone like wants to be something, or like someone wants to be a ML researcher in Google, or someone wants to be a PhD student at Stanford or whatever. So everyone wants to be something. Everyone you want to get promoted, you want to get an offer from this school or that school, but just like pause and ask yourself if you are skilled enough. Um, like if you are given that job or that position like today, would you be able to do it successfully? And so if you are not where you want to be, and if you're not working towards it, then it is like a bit of a problem, right? Um, so uh, so that is like one spectrum where we tend to prematurely sort of like wish for things. Um, so if let's say, for example, everyone wants to be the prime minister of the country, for instance. So do you have it what it takes to be like if someone made you a prime minister today, would you be able to like do the job successfully? So it is like the same thing. The problem on the other opposite spectrum is imposter syndrome. So people think that they won't be able to do a certain job, so they don't even like try. They don't even like apply, or they think that they are just not like they just won't, they don't have it in them. So that is like another problem. So like assessing your skills can be a bit tricky. I don't have any tips or anything like that. Um, I just want to say that having more like having a realistic assessment of your skills is like very, very important in life, or like for any job or any kind of educational requirement you are looking for. So yeah, that's all I have to say here. Um, so, so in the machine learning sort of and data science world, there are these days so many different titles. There is applied research engineer, then there is machine learning scientist, data analyst, research engineer, blah blah blah. And since we were talking about skills, I do want to sort of like throw a little bit of a light here. Um, so, so there are two orthogonal axes. One axis is basically science and science to engineering axis. The other axis is processing to prediction axis. So let's focus on the science to engineering axis right now. So so as you move down the list, you will move from more like writing research papers or like finding new methods, adding to say the existing pool of knowledge, and then so this would be more of like doing science. And then if you are taking the existing research and adapting them to like systems, this would come under this would come under applied research. Then if you are working on like modeling machine learning systems, this would be more like machine learning engineer. And then there would be things like building data pipelines, software engineering, systems monitoring. All these are like backbones on which the systems like models or these research systems stand on, and they are like definitely like super important. So, but we are moving into more of engineering territory now. So, irrespective of the title of the jobs, so you have to think from these two axes. One is research or science to engineering, like where does your job lie in the axis, and then the other axis is processing to prediction. So what I mean is on the top is like say data processing, or you are taking a bunch of data, making some changes, say so the tools that you would be using are more like SQL and Hadoop and Hive and things like that. So you are basically ingesting data, processing it, and then sort of like you are not making any kind of predictions, you are just transforming data. The second in the line comes data analysis. So you're not doing any predictions, but you are ingesting data and probably sort of getting insights from the data. So the job title might be say data scientist or statistician or something like that. And then on the machine learning side, it's more like predictive modeling, where you are taking the data and like making predictions out of it. So this axis is more like from the data scientist to say machine learning engineer or a research scientist. So based on where your so if the titles don't matter at all, but what your job or what your day-to-day work actually like entails, I think that is what you should look at. Um, So there is a question, how do you carve a niche for yourself? Is it recommended to go into establishing pipelines and implementing newer techniques, or dive deep into data collection biases involved, having a data-centered career? Um, so um, I don't think that this dichotomy of, say, building data pipelines versus um, so if I understand the question correctly, it's like whether you want to go into more of like engineering, building data pipelines, or whether you want to go into more of data analysis side. I think that some bit of it like everyone has to do, even like people who are say building data pipelines, they are all, I mean they also need to have some bit of like data analysis skills, etc. When you are say working in a company, um, I think it is up to you. Uh, like I would say that get very good in one of those things. So I think of it as like a T, the shape of the letter T, capital T, that you gain breadth in everything and uh, gain depth in at least one of them. So I think that is a good way to go. Um, I don't know if I answered the question, but if the question is not answered by the end of the talk, please let me know. Okay, so I am not sure if it is properly visible, but sorry, yeah, if the flowchart is properly visible, but I will just speak it out. So now, people ask this question whether they should go for a master's or not. Um, or they should go for a PhD or like nothing at all. Uh, so, um, so, like this is the flow chart that I recommend. So first of all, you need to decide whether you want to work in a specialized field like machine learning. It can be other things like say network engineering, or you could be like operating systems guy. Like there can be like so many different specialized fields. So if you want to go into a specialized field, in general, you can be, as we discussed, like you can be either more towards pure research, or you can be more towards like engineering. It's totally like up to your interests. So for instance, to give you an example, for me, I get like a lot of motivation when I actually build something that is used by people. So with research, it can be the case that although you are contributing to the knowledge base, it might be the case that it just goes nowhere. Your paper gets cited a few times, but no one is actually using that. So that kind of a feedback is important to me. Like I want to see someone like using what I built. So that kind of a work lies more in this category, like more of applied research or machine learning engineering kind of a category. So so if you want to basically go into more of like your research side, you go for a PhD. Otherwise, you if you want to go for applied research, you generally go for a master's. And uh, if you mostly want to do engineering, you want to, but still you want to do like a bit of machine learning modeling and do a bit of like data pipelining work and all that, then masters is kind of like based on your interest. You can definitely learn on the job. You don't have to do it, but it's like if you want to like go deeper, if you want to. So for me, I right after undergrad, I joined LinkedIn, and I was in machine learning team at LinkedIn. But I realized that I am not able to contribute, even though like I knew machine learning at that time. But I was not able to sort of like make any meaningful contributions to the team, except for on the engineering side. So for me, it was like very important to carve out 1.5 or 2 years of my time to, focus on just learning. So masters helped me with that a lot. And generally, it's an extremely rigorous program, which I don't think I personally could have sort of done on my own with a job and everything. So, it depends on you. You have to be like really, really kind of motivated to learn so much on your own, the way that you learn in your master's. So that is the thing. And so there are like a few simple checks. So a simple check for a PhD is like whether you want to, whether you gain pleasure in creating and growing scientific knowledge, whether you want to write papers for a significant portion of your career. You want to like develop like new things that do not exist yet, or like a simple check for whether you would want to do masters or not is so what masters allows you it allows you to it makes you good at say reading papers, and then you taking up that research and adopting it to your whatever domain you have. So um, this is like these are like two simple checks. So if you are not really interested in having a research career, then I feel that PhD comes with like a lot of lot of opportunity costs. So probably it's not a great idea, because in machine learning, even after masters, if you want to do applied research, you can get like very, very good jobs. So now there is one more aspect I wanted to touch upon. How much does a particular university matter? So let's say now you have decided that you want to go for, and yeah, one more thing. So if you are not sure about a PhD, then also masters is a very good idea. Most of the master's program in US, particularly like MS and CS kind of programs, they allow you to work with professors, and you can say try your hand at publishing 1 or 2 papers, and then you can see whether it is like a thing for you or not. And a couple of publications also help in like finding jobs. So that is like great as well, although it's not a requirement at all. So when you have decided to do a master's or a PhD. Particularly US, I'm not sure about like other like European schools and things like that, but US does have like a huge depth of schools. Even like the 50th school in US would have like a very, very good world ranking. And particularly for PhD, if you have decided you want to do a PhD, so there is a lot of competition for faculty hiring in US. So even like very, very good people, particularly in machine learning these days, so even like very good people who are graduates from CMU or Stanford, they get admits in universities like Arizona State University or Duke University or things like that, which people in India for some reason do not consider like good enough to apply or to go to. There is like a tendency to apply to like say top 20 schools, but I don't think that is like valid at all. Particularly for PhD, you are mostly working with one advisor, and if the advisor and your group is kind of like aligned with what you want to do, the school does not matter. In masters, too, school does not matter much, as it does matter a little more than a PhD, but then most of the master's programs are taken by the same profs, right? And they are like super intense, and they would require a lot of like commitment on your part. So even there, the school does not matter a lot. So yeah. Uh, Before we go any further, any more questions? So the question is, did you take masters with thesis or just the course one? How did you decide? So yeah, I took masters with thesis. Um, so at the time that I joined master, I was almost sure that I won't do a PhD. Here is how it worked for me. So I always wanted to do like machine learning. Always wanted to do something in the intersection of machine learning and social good, and like which is like kind of like extremely applied. And I think there are enough problems to be solved that you require more willingness, and I don't think it requires a lot of like research. It mostly requires like application of current techniques to this another domain. So I knew that I probably won't do a PhD, but I did want to get, a sense of how to write papers. And I feel that so so I so my program is called MCDS, Masters in Computational Data Science in CMU. So it has this capstone program where you partner with an industry and like do a project. But instead of partnering with the industry, which I was anyway going to do in my whole life, like I was going to work in an industry. So I thought I'd better use those credits to work with a prof. So I worked with a prof called Zach Lipton in CMU, and was able to publish 2 papers. So that was like a really like a very very good experience. And but still I knew that it is like I cannot do it for like 6-7 years of my life, or definitely not for like my whole life. But I did get like a very good idea about how to navigate Google Scholar, how to sniff like good papers, how to sniff problems. And so when you actually write papers, you realize uh, probably the problems or good things about other papers. So it just gives you like some bit of a perspective. You don't really need to do a PhD to be able to do that, because if you are working in a specialized field, even as masters, you would require to read through current research or whatever. So okay, I think did the Bitsian network help while getting into AI for social good? So currently, I think I am in contact with Milind, by the way. So yeah, it does help. Um, yeah. So I don't know, like I don't think I even knew at that point of time that Milind was a Bitsian. I just reached out to him and he responded. So I think um, um, yeah, just like, I mean, sometimes if you have kind of um, like if you have skills, or there are a lot of, for instance, AI for social good is a field, like there are not a lot of people that are like dying to do it, and it is still like kind of a growing field. And for instance, uh, the team in the AI for Social Good team in Google, which is like the Milind Kame's team, that as I know, they are actually like finding it hard to like find really good people to work. They don't really care whether you have a master's or a PhD, but you really need to have like solid machine learning fundamentals, right? So so for them also, it's like not easy to get people. So if you like really really like work on building your skills, um, um, I think nothing else really matters because these skills are in high demand, and yeah, it's like a very simple demand and supply, right? If you are able to supply good skills, you would definitely be in demand for. So you cannot say that NLP or say AI for social good or CV or these particular technologies would be evergreen, but you can definitely say that machine learning is going to stay for some time. So our question is how to search for a prof whose research aligns with your interests. Any roadmap for that? Um, so um, it's kind of like trial and error, and um, I think, I mean, so there is one particular website that I would recommend. It's called csrankings.org. So there you can see different profs and their number of publications and things like that in different fields. So that is where you can start from, and you can like sort by people who have published recently in particular fields. But it is not as granular. Like say it won't tell you if someone is working in graph theory, but it would generally tell you if someone is working in ML or AI or CV or like at that level or NLP and things like that. So you can go there, you can just check profs, check out like uh, those profs. You can try to read some research papers. I think that is the only way you can see like where you are interested in, like what you feel like captivating, and then try to read like more papers related to the area and things like that. Um, there is a lot of noise on the internet, like lot of resources, but a lot of noise as well. So, for instance, in NLP, I know that there is a very good blog by this guy called Sebastian Ruder. It's called NLP-progress. So that is something you can look at. So if you're interested in NLP, there are like all the subfields are divided very nicely, and you can look at the latest papers and things like that. Other than that, I feel a good way is to like just do basic 101 courses. So when you do say NLP courses or CV courses or reinforcement learning courses or any of these basic courses, you naturally get inclined to a few of these um, particular ideas, and then you can find more about them. And then you can try to find out profs in those areas. So I think these are the only ways to do it. So it's mostly trial and error. Um, let's see, there are a few more questions. Um, do you feel doing thesis in undergrad helpful for the master's application? Um, I so master's applications are kind of black box. I don't really know. I think it depends on. I think recommendations and even if you have not done any research work is good. But if so publishing papers in undergrad is really really hard, which most of the people don't have. And if you don't have that, then I mean, thesis is good. I don't think it is you have to do it or anything. Uh, yeah, so I don't think that it is like fair, like it is kind of like it would be like the most important factor in your application. I feel that recommendation letters are one of the more important things for masters. Um, okay, let's see. Okay, I think that's all. Yeah, okay, there is one more. As you mentioned about sniffing good papers, can you throw some light on how to effectively read a paper? Okay, that's a good question, and I don't think I have like time to, it's kind of like orthogonal question. I'll just go into it very briefly. So one is that when you read enough papers in an area, and when you know like the boundary of that area, if a new paper comes in, you would like get an idea. It is not very hard to get like perspective on whether this kind of a work is done in the past, or you can do like a quick search to find that out and things like that. And then if you say start with a few classic papers, let's say BERT is a popular model people use these days. So if you just pick up BERT paper and look at the kind of experiments that are done. So if you have like a kind of like a mental blueprint of like just a few papers, you would like know the difference between like good and bad papers, like the kind of experiments, the number of experiments that are done. There are a few benchmark NLP data sets, whether the paper is doing experiments on that. So a good way to read papers would be like, for instance, if I have to skim through a paper, I look at the abstract, and then I skim through the introduction if the abstract does not make things clear. Most of the time, if the paper is written nicely, the abstract does make things clear. Then I directly jump onto the experimentation section, and I quickly look at there is generally like a large table of results. I'm mostly talking about like empirical NLP because those are the papers I end up reading. So it might be different for different fields. So don't quote me on this. And then I would like look at the conclusion. So so if you are occasionally familiar with the area, it takes around like this whole thing takes around like 10 minutes. Okay. So did you feel getting a powerful local machine is a better idea, getting into cloud computing? So, okay, this is a very specific question, that whether you should get like a local machine or go into cloud computing. So that is, I feel, like a personal preference. If you are training deep learning models, I feel that go on cloud because GPUs are extremely expensive, and getting a powerful CPU is not a bad idea for a computer science person. Um, if you are using, even if you are using like say a lot of browser, or say like a heavy duty code editor, you should get like at least a 32 GB RAM, in my opinion. Okay, so I think we are done with all the questions. Okay, so now I wanted to talk a little bit about whether you should think of going into like a bigger company or a startup. So what I have seen, I'll come to these points, but just want to mention one small thing. So my friends who got into like say Google or Facebook right after undergrad, I feel that those people did not end up doing masters. People who got into say LinkedIn like me, or Microsoft, or some other companies, or people who obviously like decided to do some research thing or something like that, those are the people who actually ended up doing masters. So I have seen that it happens that when people like join like a bigger, like more stable company, particularly like Google is the culprit, they tend to not leave it. um, so I just feel that if you join a bigger company right after undergrad, that's fine, but don't make it like end all be all. If you think that, I mean, your growth should not be hindered by you getting into like a good company, or for that matter, a growing startup. So coming back to like a bigger company or a startup. So for a startup, I feel that the belief in like the vision of the company is like super important. So let's take any startup. Let's say, for instance, Grammarly is a startup, right? So what they do is they check for grammatical mistakes in your writing, right? So if you like really believe, you have to really believe in the mission of the company that solving or like checking for people's grammatical uh, problems is something that you really want to solve with your skills. So I feel that that is much more important for a startup than for a bigger company. Just because in startups you might have to give your sort of like a lot. You have to work for longer hours, and you might have to work outside your comfort zone and things like that. The second thing is whether you want to do like a very, very specific thing really, really well, or you have more of an exploratory attitude where you want to sort of like dive into many different things. Like, for instance, let's say there is a network outage one day, and you are like, let's say you are hired for doing machine learning. So you are totally, you have this attitude that, oh wow, it's exciting. I'll get to learn more about networks. So if you have that kind of an attitude, like definitely like go for startups. There are some people who get like very bored working on like a very small like niche area in which happens mostly in bigger companies. So and the other thing is like your risk appetite is much more when in earlier parts of your career than in later parts. So yeah, why not like just like explore something exciting. um, Another thing is development environment. So bigger companies have like very, very established, say, machine learning pipelines or deployment tooling and things like that, which makes the job extremely easy. So again, like it again comes to like specialized versus exploratory attitude. So that makes the job, you just have to focus on your very small slice. So that is like a different experience. These days, it is changing with like both enterprise and open source solutions to tooling. So these days, this is changing a little bit, but still overall, I think development environments are much more robust in bigger companies. Um, the fourth part is growth. So in bigger companies, there can be things like bureaucracy and other challenges. Um, there can be variance from team to team. If your team, let's say you are in some team in say Google search. So now Google search metrics are so stable that it is like extremely hard to move them. And that is sometimes directly tied to your growth. So, uh, so if you are just concerned about like learning, which I think should be the goal at this point in the career, it should not matter much. But if you really want to like get 2 or 3 promotions very, very quickly, then probably like middle-sized companies or like growing teams in bigger companies might be a better choice. Okay, so one more question. Just on a lighter note, would you be exploring other specializations in ML/AI, like applications with cryptography, etc., or does your way remain fixed deterministically now? Okay, that's a very good question. So, for me personally, I am not like I would like love to learn new technologies, and I would come to this point later in the talk. Like you should not sort of like silo yourself. Just because you have some skills, that does not mean you cannot gain new ones, or whatever. So I feel that machine learning is kind of like a generic tool in your toolbox. You can you can sort of like combine it with anything, any of your other interests, and it's like it's almost like learning to program, right? If you are a good programmer, you can like do you can learn other aspects, right? But this is just from the point of intellectual satisfaction. From that perspective, I would love to learn more things, but I really want to work in the like start like I am very keen to start working in the intersection of AI and social good. So I tend to think backwards from the problem. This might not be the only way to think, but how I think is that, okay, you have to solve this particular problem, and how you go backwards from that problem and add toolkits. So, for instance, CV is not my strong suit. And one of the problems that in Vadhvani AI, which is like again works in AI for social good. So one of the problems that they are tackling is uh, pests on cotton fields, right? So I start backwards from there, right? So I might have to gain more expertise in CV than I currently have to be able to solve that problem. Um, some other people are more get more excited by the techniques, and then they use it as a hammer and they find like nails to that. Approach is completely fine as well. But yeah, this that is just how I tend to work. I need to have some motivation or some impact insight to be able to learn something. Yeah, that is just me. Okay. So yeah, so I touched upon this a little bit, but since we talked about like there are so many different job titles and there are like so many different places you can apply to, and so some of the things that you need to keep in mind when deciding for a job. So this is like an inverted triangle. So for instance, uh, uh, so uh, first of all, to make the idea here is to make sure what exactly you would be working on a day-to-day basis, and how you will be contributing to the larger goals. So I feel that these are the questions that are sort of like most effective. So how exactly will your performance be evaluated? So for instance, I'll give you an example. So there are people who want to do research in their roles, and they are, and companies also, teams also like sort of tell people that, okay, yeah, we write a lot of papers and to just attract people, right? So if that is really the case, then it should be that your performance is evaluated on the basis of writing papers. If not, then I think like it is a problem, right? Like your goals and your employer's goals do not align. So this is like the first question. And then what part of the team's objective would my role fulfill? So let's say your team is working on this super cool, whatever, augmented reality application, and you are like gravitating towards the team, but your particular role is building, I don't know, um, like connecting two modules together or writing data pipelines or things like that. This is what you are being hired for. So you should just be like clear. like where exactly do you lie in the team? So this has happened with me in past where I joined a team based on what the goals of the teams are, but I did not really ask a lot about what my role exactly is going to be. Why am I brought into the team? Um, so that is another important thing. The third is, what does a project life cycle look like? So this might be important to know. Like, there is no right or wrong answer. Um, uh, it's just that it is like good to know whether projects are more like 2 years long-term projects, or whether projects are more like 3 month kind of a project. So that you just have, let's say, you are sure that you want to apply for masters, let's say, and then you probably want to be in a team which have more shorter turnarounds, so that you can sort of like show off your accomplishments in your master's applications. So again, like, this is like a enlightening question to know about. The last thing is, what are the tools I would use the most? I feel that tools or programming languages or whatever, I feel that this question is important to know where you lie on the processing to prediction axis that we talked about a few slides before. Basically, if you are using more of, say, R, Python, SQL, probably you lie more on like the data analysis side of things. If you use more of, say, TensorFlow or deployment pipelines, or I don't know, like whatever, PyTorch, etc., you probably lie more on the machine learning side. So I feel this is again like the more an enlightening question to ask. So there is a question. Which soft skills do you recommend in undergrad? Um, so that is a good question. So I think I myself neglected, like, I feel that communications is like, how much ever you can improve it, there is always a scope. So just presenting yourself and your skills in humble but like sort of firm manner is like a thing that, and like more importantly, technical communication, um, like and to do like and to do like the technical communication, like to improve on the technical communication, the best way I feel is to think of, or like look at system design problems or machine learning design problems. Things like, how would you design a recommendation system, and sort of like just speaking out the steps one after the other. So that kind of a thing would make you uh, think from like an engineer's perspective. It would tell you gaps in your knowledge, and it would like help you sort of like gain mastery in interview settings as well. So I feel that just these case study, like practicing these case studies and practicing your technical communication, is kind of like very good. And just know, like, what do you as an individual bring on table. So for instance, I feel that so if I worked in the trends team at Twitter. I feel that I was one of the people who was most concerned about health of the trends. Like, we are not showing any abusive, or we are not harming anyone, or we are not biased towards certain groups. So these are the things, this is the perspective that I brought on the table, that other people probably, like, not all of the people had. So just like know, what if you bring, say, strong, very, very strong technical skills, if you so just know, like, what are your like strengths. So yeah, these two things. Um, Other question I have is, did you connect with your master's peers and do you find collaborative projects helpful? So, yeah, so I think I learned most from my peers more than anyone else in masters, uh, and um, I did have like we were like three people who used to do a lot of like our projects together. I do feel that I went out of my comfort group of those three or four people and did projects with other folks as well. But yeah, so definitely you learn a lot from your peers like all the time. Um, so yeah. Uh, okay. Um, so let me quickly, I think we are out of time. So Chaitanya, how much time do we have left?
Ma'am, I think around about 15 minutes to half an hour.
Okay, okay. Okay, then I'll quickly skim through the slides, and if there are any questions, please keep asking. I'll make sure that I answer them. Uh, so yeah, so now coming to the juicier aspects, which is money, and how, like just my 2 cents on how to think about money, how important is money for you. So I just put this graph as a reference. So this graph shows on the x-axis, it shows like uh, how much money you made, and this is like a sort of like a log scale. So like in every unit, the amount of money doubles. So for instance, after it's I think 4K, and then it becomes the next unit is 8K, and then the next is 16K, and so on. So it is a log scale. And the y-axis is a linear scale. This is just like the people's self-satisfaction, like reported self-satisfaction. So as you will see, like people's satisfaction increases by 1 unit when their money kind of like the money has to like double for people satisfaction to increase from 1 unit. So for instance, if you look at India, um, for their satisfaction to go from 5 to 5.5, the money had to increase from 4K per annum to 8K per annum. So it does not. So basically, you have to earn double the money to like sort of have increase like a little bit in self-reported like life satisfaction. So just this graph is just for perspective. So money is something that people optimize for just because it can be optimized. It is something that is numerical, and when you have that kind of like an engineering optimization kind of a mindset, you just need something to be optimized, and you would like just go all for it. So I feel that that kind of an attitude. And one another thing is that if you are optimizing for money, I think that there are probably better ways than doing software engineering. Probably like if you go in finance, if you do things like quant trading and things like that, probably those are more optimal choices. If you are like most of the other people where money is important, but like it's not the end all be all, then I feel that one way that I think about it is that I fix a certain amount, that okay, this is what I need for my comfort or survival, and um, anything after that, I would just optimize for other things in life, so that I do not end up get it. So I do not get sort of like enticed by monetary factors a lot. So yeah, just my 2 cents here. Um, Now, the final thing, and I think the most important thing is personal fit. So, so the most important thing is to know yourself. Like, I don't think most people know themselves really well, and it also takes like a few years of, say, working in an environment to know what kinds of environment you thrive in. So for instance, if we were talking about academia versus an industry, there is a very different feedback cycle. So, for instance, in academia, there is uh, like no one really, because you are like paid less, no one really cares about what you are working on, and except your advisor, and even your advisor would be like, they would not be checking in with you even weekly sometimes, right? So you have to be extremely self motivated, and it can get like a bit hard sometimes. So if you are like generally a self motivated person, uh, then probably academia is for you. Otherwise, like, probably you should rethink it. Then support, like, do you have how much support do you need in and around your team, and in your group or things like that. Again, I feel that in academia it can be the case that, so you are the only person who is working on like a very very niche thing, and even the other people in your group are generally working on different things. So if you it can be like a bit lonely sometimes. Uh, Independence. So independence is something is that comes in academia, and some people like my husband, they are like, they would give up anything for independence just to be able to work on anything that they want. So I feel that it's a major plus in academia. In industry, you can, but even in academia, like, if you sort of like choose that this is the topic you want to work on, obviously tomorrow, like, you cannot change your topics every 3 months or something, otherwise you will not graduate. So it's not like you can do anything, but still it's much more independence yeah, it allows than in the industry. And then work life balance, that can depend from team to team, or in academia, you mostly decide for yourself how much you want to work. In industry, it really depends. There are people who just cruise for years and years in bigger companies, and there are people who work for 70, 80 hours a day in a startup. So yeah, it depends. But still, you should know what works for you, and it can keep changing from phases. People have phases in life. In some phases, like, they are super productive. There are phases in life when you really don't want to, where you want to like sit back and relax a bit. So it keeps changing all the time. But just be sort of like cognizant of these facts. So how to find a good personal fit. So how to find a niche for yourself. I think that was a question that someone asked. Uh, so how I do it, or how I've seen people around me do it, is like, have a long-term vision. So um, like for me, like a vague long-term vision is that I want to create something impactful. It's it's kind of vague, but still, like, I want to create something impactful that affects grassroots masses, and I want to do it through technology. So this is like my vague vision, and so something like that is, or you can have like you should have some vision, even though it might be vague. That's totally fine. and then you take like tiny steps towards those vision. And if you find opportunities, or you keep a lookout, or for those opportunities, always keep taking tiny steps day by day and look out for like major leaps. Then in over a period of 6 months or 1 year or 2 years, or even more than that, like 2 3 years, you reevaluate whether your vision still stands, and then like repeat. uh, so um, and it's totally okay for your vision to change, but it is very important to have any like have some long term vision, at least, even if that vision is that I want to be a billionaire by the time I am like whatever 40. So that is also like at least some vision. You The steps that you would take would be directed towards something. If you change your mind later, if you want to change your vision, like, all power to you. It is not written in stone. Um, so yeah, I before I have like I think one more slide, but I would want to ask the audience if anyone has any more questions. So the question is, when you started learning AI ML, did you explore many subfields, or learn or select few subfields in deep? Okay. So yeah, so I did have a tendency towards linguistics. Uh, in general, like I had an interest in linguistics even before I started machine learning. So I think NLP was more of like a natural choice for me. But at CMU, I did at least dabble in different subfields. Like I did a little bit of CV, I did a little bit of reinforcement learning, and then classical machine learning. Uh, got a little taste of theory as well. Did like a very theoretical course. Um, so um, so yeah, I think NLP seemed like a good fit for me at that point of time, and that is what I sort of like became an expert in. But yeah, I do not want to like stay forever in NLP. It's just good to have something. Um, it's just good to have something that you can call your strength. It just gives you perspective on how much or how little you know about other fields. So um, so yeah, um, and generally, if you're not going for a PhD, even if you're going for a PhD, you can. I have seen many people who thought that they liked robotics. They started, for instance, masters in robotics, and then they realized that they want to go in theory. So after 2 years, they completely changed their fields, and they started doing theory, and now they are like they doing it from scratch. I know some people who try to do theory like me, but realized that it's not for them, and um, started doing more empirical things. So people uh, uh, like, don't be afraid to like change. If you think that something is not for you, it's not like a failure on your part or anything like that. It's just like your temperament, and probably a lot of things you cannot change. So, and I feel that when I was in undergrad, I used to think about 6 months or 1 year or 2 years, say, spending on something as waste of time, and all hell would break loose if I waste 1 year or 2 years. So I used to give like a really huge premium to that, but it doesn't really matter in the long run. 1 2 3 5 years don't matter if you are learning at least something in that period of time. Okay, so the next question is, While working on a research paper, did you ever get stuck without getting any ideas on how to develop novel architecture to improve results? What was your motivation in such situations? Yeah, so that is a good question. So uh, there have been cases. So I have so I do not have like a lot of experience in writing papers, but the ones that did go through, it was not like they, for instance, went through in one go. It is like a very long. You need to have like a lot of patience, and they are like long projects. So generally, how it works is that you feel that there is a gap in the field, and you have a hypothesis. You do some small experiments to see if your hypothesis is even like correct. Um, if if the small experiments fail, most of the time you realize that probably the larger, longer term experiments would fail as well. So you don't go any further. So these kinds of failures, I have like had many such failures. Um, I so the question asks, did you ever get stuck without getting any ideas on how to develop novel architectures to improve results? So for me, none of the papers that I wrote was actually relied on developing novel architectures. Uh, or they were focused on improving results of a particular task. Um, more like much of the research, much of the, let's say, stereotypical research is that way, that let's say there is a task, say whatever, like POS tagging, and you are improving results on POS tagging. But my the research that I worked on was not in this category at all. So for instance, one of the papers that I worked on was introducing a new data set for introducing a new question answering data set, because we felt that there is no one standard e-commerce question answering data set available. And like running say standard models to get whatever the results on those data on that data set, and comparing it with like other models. And the other papers I worked on were some of them were related to probing. So for instance, like finding out like uh, related to explainability of neural networks. So basically finding out what happens if I change certain things or tune certain things, or what happens if there is a mechanism called as attention mechanism. What happens if I try to distort it? So they were more of like probing kind of questions. So again, like in these kind of questions are probably more on the safer side, because you are only there can be surprising results which are more likely to be getting published, but most likely it's just a gap and no one knows the answer to it, right? And you just do experiments to find out the answer. So um, um, yeah, so I guess I answered the question. Yeah. So everyone says that they make some projects. How did you start your journey with these projects? Okay. So um, that okay. So let's see. So the projects that I have are either um, in bits. Like the projects that I would have would be just like class projects. So for instance, there was a project in parallel programming, there was a project in data analysis and algorithm. Everyone builds all CS students build a compiler, and all those your regular projects. And then I did a bunch of study oriented projects. And so, yeah, I think my undergrad projects were not impressive at all. So if I was there in undergrad right now, I would probably try to collaborate with PhD students or um, uh, researchers. Like first, like try to improve. Let's say I want to work in deep learning. What I would do is I would like get really good at PyTorch or TensorFlow, or get really good at implementing, say, neural networks. And let's say I would reach out to a few PhD students. And so PhD, the people who are pursuing their PhD, they are always on lookout. So they always have a lot of ideas, and they are on lookout for people who can implement it for them. And I feel that this kind of a collaboration is fruitful for both the parties. So undergrads can sort of like um, learn from the PhD students, and the PhD students can get more or less free help, So I would probably do that. I would also take better SOPs with profs. I would probably reach out to profs in other universities during summer or in holidays, or even during the semester, or things like that. So if I was an undergrad, I would do these things. But I did not do any of these things. Other projects that I did were in Linden, and then at in masters at CMU, the most like I took courses which had like the project as like a huge component. Let's say 70-80% of a course was a project. And then, as I mentioned, there were like a set of 4 courses, there was a project that was equivalent to 4 courses, where I got to do like a lot of research. And then I just like kept collaborating with Zachary Lipton, who I worked on with my master's, even after my master's. Then I did some projects in the startup that I worked on. Uh, uh, so they were working on an open source project. Yeah. So another thing is, open source projects are another way to sort of getting yourself involved in something. It is like a bit hard to find a project that find like an open source project that requires your exact skill set, and where you can sort of like contribute, but that is like something tangential that you can like show off on your resume or whatever. So these are a few ways as an undergrad you can do these projects. I would say just like keep tinkering with things. There are so many resources and materials available online. Just like uh, keep doing something. Yeah, that's all. Okay. So the next question
Excuse me,
is,
ma'am. Actually, the
sorry.
session is automatically scheduled to end in about 7 minutes, so I don't think we can
Okay.
take any more questions. So after
Okay.
the
I'll just take the question that we have. Okay, so the question is, on a side note, getting into big tech companies either by absorption through summer intern, PPO, or placements requires good competitive coding skills. What are your views on this research projects competitive coding trade-off? Um, yeah, this is a very good question. So so I feel that um, doing research projects, you might not get um, enough opportunity once you are outside of university, um, just because most likely you would be working somewhere, and it is just like, if you're not doing masters, it is hard to do projects on the side in general. So I feel that in undergrad, at least one or maybe best case two research projects um, should be the goal. Um, and as per competitive programming, I feel that your basics should be good, and competitive coding does help, but most of the companies ask, say, lead code medium kind of questions, like not very hard questions. There are only finite questions in the world, I feel. And if you are able to do those, like probably 100, a set of 100 questions that are asked in many different ways, you should be able to sail through. I feel that many people are not able to do, like based on my experience with interviewing, etc., many people are not able to do very basic questions, um, which is not a good sign. So yeah, I just feel that um, it is, you don't have to do like you don't have to be a competitive programmer to get a good job. You just need to be good at DSA and basic data structures and algorithms, and just communicating well. So something that people do, like say a lot of competitive coding, or they will do a lot of lead code, but something that most people like sort of like not do is take practice interview sessions. So there are services like Ramp, and there are, I think, even on lead code, you can schedule online interviews, etc. uh, like friends can take sort of these interviews for each other. You can ask your seniors or people who are in uh, who are working to take to take these interviews for you. So I feel that mock interviews are like a really undervalued resource that people should do more often for getting the job. Okay. Okay. Anything else? So another question is, could you share your cold emailing journey? Uh, I uh, I cold emailed a lot of people right before. When I got admissions in a few masters program, I cold emailed a lot of people if they would like to work, if they would work with me, and I'm joining this if I join this university. And some of them replied, some of the profs did reply. I cold emailed their PhD students again. Some of them replied, some of them did not. Um, Whenever I'm changing a job, I cold email a lot of past colleagues, and or just like people who I have had some interaction with in the past. I don't know, that would not be probably cold emailing, but yeah, like I email people out of the blue. What else? Yeah, I think that is all my experience has been. So there is a method to cold email. You should know what you are bringing on the table. You should be familiar with the uh, like the research or whatever people are working on. You just cannot cold email writing, "Hi, sir, I would like to work with you," because I have seen people do that. So that is not the way to do it. You tell what you work on the table. You tell people what you bring to the table and what you want to gain from whatever experience you are looking for. So yeah, I think that is about it.
If there are any further questions, they can be asked in the table. There's no problem with that. Now to conclude the session, first of all, I would like to thank Ms. Mansi for coming to the session, taking some of her valuable time and guiding all the students. I would also like to thank all of the students and everyone who has attended the talk and making this a great success and asking really inquisitive questions. So, with
Thank
that,
you,
we end
everyone.
this session. With that, we end this session.